Good morning, dear students. Today we are going to discuss about oxidation and reduction. In this part, we consider two important concepts regarding oxidation and reduction. First concept is electronic concept of oxidation and reduction. Electronic concept. What do you mean by oxidation? According to the electronic concept, a process in which an atom, molecule or ion loses one or more electrons is called oxidation. So oxidation is loss of electrons. Simply we can say that loss of electrons, that is oxidation. Then what do you mean by reduction? According to electronic concept, reduction is a process in which an atom, molecule or ion gains one or more electrons is called reduction. Simply gain of electrons, that is called reduction. Then what do you mean by oxidizing agent? Oxidizing agent, or it is called oxidant, is one which removes electrons from a species and thereby brings about oxidation. It's oxidation. That is oxidant. Oxidant helps to remove electrons. Helps to remove electrons. That is oxidant, or it is called oxidizing agent. Whereas a reducing agent, or it is called a reductant. Reducing agent, or it is called a reductant, is one which donates electrons from a species and thereby brings about its reduction. Simply, reductant helps to accept electrons. Reductant helps to accept electrons, thereby brings about its reduction. Or an oxidant itself undergoes reduction. Whereas a reductant itself undergoes oxidation. Oxidation and reduction always occur simultaneously, and the combined process is called a redox reaction. Combined process is called a redox reaction. For example, consider the reaction, that is 2 magnesium plus oxygen gives 2 MgO. That is a reaction. Consider this reaction as two half reactions. That is, this reaction can be split into two half reactions. One is oxidation half reaction, another one is reduction half reaction. In the case of magnesium, 2 moles of magnesium converted into 2 moles of Mg2 plus by liberating 4 electrons. 2 magnesium converted into magnesium 2 plus by liberating 4 electrons. Then what happens to oxygen? Oxygen gains 4 electrons and converted into 2 O2 minus. 2 O2 minus. Then what is the overall reaction? Overall reaction can be represented as 2 moles of magnesium reacts with the oxygen to form 2 moles of Mg2 plus 2 moles of O2 minus. That is, this ionic states combine to form 2 moles of magnesium oxide. 4 electron and 4 electron cancelled. This 4 electron in the product side cancelled with this 4 electron in the reactant side. Then overall reaction can be written as 2 Mg plus O2 gives 2 Mg2 plus 2 O2 minus. Here, oxygen brings about the oxidation of magnesium. Here, oxygen acts as an oxidizing agent by removing electrons from magnesium. Here, magnesium loses electrons. So, oxidation helps to lose electrons from magnesium. So, oxidant is oxygen and itself undergoes reduction. What is the case of magnesium? Magnesium brings about the reduction of oxygen by donating electrons to it, and thus is called the reducing agent. Magnesium is called a reductant and itself undergoes oxidation. Magnesium itself undergoes oxidation. Oxygen itself undergoes reduction, and oxygen helps to oxidation of magnesium. So, oxygen acts as an oxidant, magnesium acts as a reductant. The reaction shows that oxidation and reduction always occur simultaneously and hence forms an example for a redox reaction. Then consider another redox reaction, that is 2 moles of sodium Na plus chlorine gives 2 moles of NaCl. This is the reaction. This reaction can be split into two half reaction. First one, consider the case of sodium. 2 moles of sodium liberates electrons converted into Na plus, 2 moles of Na plus by liberating 2 electrons. Then what is the case of chlorine? Chlorine accepts 2 electron and converted into 2 moles of Cl minus. Then what is the overall reaction? Overall reaction can be written as 2 moles of Na plus chlorine gives 2 moles of Na plus 2 moles of Cl minus. That is 2 moles of NaCl written in the form, 2 moles of NaCl. 2 electron in the product side and 2 electron in the reactant side will cancel each other and it is converted into 2 moles of Na plus chlorine gives 2 moles of NaCl. This is the overall reaction. Here chlorine brings about the oxidation of sodium by removing electrons from sodium. Here, so chlorine acts as an oxidizing agent. Chlorine acts as an oxidant and itself undergoes reduction. Sodium brings about the reduction of chlorine by donating electrons to it. By donating electrons to chlorine. Thereby, sodium is the reductant. Sodium is the reductant and itself undergoes oxidation. So, this is another example for redox reaction. Next is oxidation number concept. What do you mean by oxidation number? It can be simply represented by On. Oxidation number of an element is defined as the formal charge which an atom of the element appears to have when the electrons on the atom in the molecule are counted in accordance with the following rules. That is, the electrons shared between two like atoms are divided equally between the sharing atoms. Second rule, electrons shared between two unlike atoms are counted with the more electronegative atom. That is, consider the Lewis structure of fluorine molecule. This is an example for a molecule which contains two like atoms. This is the electronic distribution and this is the sharing of electrons between two fluorine atoms. So, in the case of like atoms, electrons shared between two like atoms are divided equally between the sharing atoms. So, here upon dividing the electrons shared between the two like atoms equally between them, then there is no formal charge appears on either fluorine atom. This means that oxidation number of fluorine in fluorine molecule is 0. Here, two electrons shared between these fluorine atoms. So, they are equally shared between them. So, there is no formal charge appears on fluorine atom. Thereby, its oxidation number will be equal to 0. Then consider the case of a molecule which contains unlike atoms. That is here hydrogen and chlorine. One electron contributed from hydrogen and one electron contributed from chlorine. That is, this is the sharing of electrons between these two atoms. But it is a unlike atoms. So here upon counting the electrons shared between the two unlike atoms hydrogen and chlorine with the more electronegative chlorine, more electronegative atom, that is chlorine. A formal charge of -1 appears on chlorine and a +1 appears on hydrogen. That is the formal charge of hydrogen and formal charge of chlorine. This means that oxidation number of chlorine in HCl molecule is -1 and that of hydrogen is +1. Then we have set of rules for determining the oxidation number of an element in a molecule or ion. First rule, oxidation number of any element in the uncombined or elemental state is 0. Second one, oxidation number of fluorine in all its compounds will be equal to -1. The other halogens too have an oxidation number of -1, that is chlorine, iodine, bromine. All these halogens have oxidation number of -1 when they are bonded to less electronegative atoms. Then third rule, the group of first elements, that is our alkali metals like lithium, sodium, potassium, rubidium, cesium and francium. Oxidation number will be equal to +1. And the group of second elements, that is our alkaline earth metals like beryllium, magnesium, calcium, strontium, barium, etc. Their oxidation number will be equal to +2 in their compounds. Then fourth rule, oxidation number of hydrogen is +1 in all compounds except in ionic hydrides, that is sodium hydride, that is a ionic hydride, or calcium hydride CH2, that is another ionic hydride. In this case, oxidation number of hydrogen is not +1, whereas all other compounds hydrogen possess oxidation number of +1. Then fifth rule, oxidation number of oxygen is -2 in all compounds except in peroxides. What is the formula of peroxide? H2O2. That is the formula of peroxide. Peroxides, here its oxidation number of oxygen is -1. Similarly, in superoxides, its oxidation number will be -1/2, etc. Then sixth rule, in neutral molecules, the algebraic sum of the oxidation numbers of all the atoms will be equal to 0. In neutral molecule, sum of oxidation number will be equal to 0. Then for ions composed of only one atom, oxidation number is equal to the charge on the ion. Whereas for polyatomic ions, the sum of oxidation numbers of all the atoms is equal to the net charge of the ion. So oxidation number will be equal to net charge of the ion. Net charge of the ion in the case of polyatomic ions. For example, calculate the oxidation number of manganese in KMnO4, potassium permanganate. This is a neutral molecule. So, in the case of neutral molecule, apply sixth rule. Algebraic sum of oxidation numbers of all the atoms will be equal to 0. Then, how can you find out the oxidation number of manganese? Let oxidation number of manganese be X. That is the value we have to find out. Then oxidation number of potassium. According to third rule, we know that oxidation number of potassium will be +1. Then oxidation number of oxygen. According to fifth rule, oxidation number of oxygen is -2. Oxidation number of manganese is X. Then apply sixth rule, that is sum will be equal to 0. So +1 plus X plus 4 into -2. Here 4 oxygen atoms are present. So 4 into -2 will be equal to 0. That is X minus 7 equal to 0, or X equal to +7. That is oxidation number of manganese in KMnO4 will be equal to +7. The next is calculate the oxidation number of chromium in Cr2O7 2-. This is a polyatomic ion. So apply seventh rule. That is, in the case of polyatomic ions, sum of the oxidation numbers of all the atoms is equal to the net charge of the ion. There is net charge of -2. So sum of oxidation number of all atoms will be equal to -2. Then consider the oxidation number of chromium Bx. Then oxidation number of oxygen is -2 according to fifth rule. So we can write 2x, 2 moles of chromium, so 2x plus 7 into -2 equal to -2. Net charge is -2. That is 2x minus 14 equal to -2, or 2x equal to -2 plus 14, that is equal to 12, or x equal to 12 by 2, that is equal to 6 plus 6, or simply we can say that oxidation number of chromium in Cr2O7 minus is plus 6. Then according to oxidation number concept, oxidation is a chemical process which involves an increase in oxidation number of an element, and reduction is a chemical process which involves a decrease in oxidation number of an element. A process in which there occurs changes in the oxidation numbers of elements in that interacting species is called a redox reaction. For example, consider the reaction between manganese oxide MnO2 and HCl. MnO2 plus 4 moles of HCl reacts together to form manganese chloride MnCl2 plus Cl2 plus 2 moles of water. Then which is an oxidant, which is reductant? A substance which brings about increase in oxidation number of an element in another substance in a reaction is called the oxidizing agent or oxidant. So oxidant helps to increase the oxidation number. Oxidant helps to increase the oxidation number of an element, whereas reducing agent or reductant helps to decrease the oxidation number of an element. So in this reaction, which molecule is an oxidizing agent and which is reducing agent? So let us find out the oxidation number of all the atoms present in this reaction. So first one, MnO2. Here oxidation number of oxygen is -2. So oxidation number of manganese will be +4. Then this is HCl. So oxidation number of Cl is -1. Oxidation number of hydrogen is +1. Then in the case of manganese chloride, for chlorine oxidation number is -1. So oxidation number of manganese will be +2. -1 into 2, that is -2. So manganese, oxidation number of manganese will be +2 in order to maintain neutrality. Then oxidation number of chlorine, that is an chlorine like atoms, so oxidation number will be 0. Then consider oxidation number of atoms in water. Hydrogen, oxygen minus 2. So hydrogen plus 1. These are the oxidation number of elements present in the reaction. It is seen that the oxidation number of manganese decreases, here plus 4, here plus 2. So oxidation number of manganese decreases from plus 4 to plus 2, indicating that manganese oxide has undergone reduction to manganese chloride. The oxidation number of chlorine increases from minus 1 to 0, showing that HCl has undergone oxidation to chlorine. That is, we can say that manganese oxide causes the oxidation of HCl to chlorine. Also, manganese oxide contains an element manganese which suffers a decrease in oxidation number during the reaction. That is, manganese oxide is the oxidizing agent. Oxidant. Oxidant itself undergoes reduction. There is a decrease in oxidation number. So itself undergoes reduction. So it is an oxidizing agent or oxidant. Whereas chlorine undergoes increase in oxidation number. That is, itself undergoes oxidation, or it is a reductant or reducing agent. Consider another reaction, and which will be oxidizing agent and which will be reducing agent. Here, oxidation number of each atom in this reaction. Sulfur having oxidation number minus 2. So hydrogen oxidation number plus 1. In the case of HNO3, oxygen having oxidation number minus 2 and hydrogen having oxidation number plus 1. So nitrogen has oxidation number plus 5 in order to maintain neutrality. Here minus 2 into 3, that is minus 6. Minus 6 plus 1 plus 5, that is plus 6. So plus 6 minus 6 equal to 0. Then in the case of NO, oxygen minus 2, so nitrogen plus 2. Then sulfur elemental form, so oxidation number will be equal to 0. In the case of water, oxygen minus 2, hydrogen plus 1. These are the oxidation number present in all atoms. Here oxidation number of nitrogen decreases from plus 5 to plus 2. Plus 5 to plus 2. That is a decrease in oxidation number, indicating that HNO3 has undergone reduction to NO. Oxidation number of sulfur, here minus 2, that is increases to 0. So H2S has undergone oxidation to sulfur. Or we can say that HNO3 causes oxidation of H2S to sulfur. Also, it itself undergoes decrease in oxidation number. That is, HNO3 acts as an oxidizing agent. Itself undergoes reduction. So that is an oxidant. And in the case of H2S, which helps to the reduction, of nitric acid to NO, and H2S itself undergoes increase in oxidation number, that is oxidation. Itself undergoes oxidation. So H2S acts as a reductant or reducing agent. That's about oxidation and reduction reactions. Hope it is clear. Thank you.